All right, welcome. Today we're diving into the fascinating two-sided story of blood clotting. We're talking about how our body's own life-saving superpower can sometimes, well, go rogue and become a silent villain.
Think about it for a second. That incredible ability your body has to stop a bleed, to plug a leak. It's basically a biological miracle. But what happens when the very same system that's designed to save you decides to activate under the wrong circumstances? What flips that switch?
And that brings us to our key term for today, thrombosis. So this isn't just any old clot. This is a clot that forms inside your circulatory system, your veins, your arteries, or even your heart while you're alive, right where it's not supposed to be. And that clump of clotted blood, that's called a thrombus. The big question is, how does one of these even start to form?
Well, it turns out it's not just random bad luck. There's a very specific set of conditions that create the perfect storm for a dangerous clot. So let's get into the origin story. You can almost think of it as the recipe for thrombosis.
It pretty much boils down to these three ingredients. Now, you don't always need all three at once, but one or more of them is almost always in the picture when a dangerous thrombus forms. So let's break down each part of this recipe one by one.
Okay, first up, endothelial injury. I want you to picture the inside of your blood vessels as having this perfectly smooth, almost Teflon-like non-stick lining. But when that lining gets damaged, say from plaque buildup, the stress of high blood pressure, or even toxins from cigarette smoke, it becomes rough and sticky. This is a huge trigger, especially in your fast-flowing arteries.
The second ingredient is all about the flow of traffic. Normally, your blood moves in a really smooth, orderly way. We call that laminar flow. But when that gets messed up, you get one of two problems. You either get turbulence, which is like a chaotic, swirling traffic circle, or you get stasis, where the blood flow slows down to a crawl, almost like a stagnant pond. And neither of those is good news.
So what's causing these internal traffic jams and stagnant pools? Well, things like plaques can create that chaotic turbulence. Aneurysms, which are these bulges in an artery wall, create little pockets where blood can just sit and pool. And after a heart attack, some parts of the heart muscle might not pump right, leading to stasis right there inside the heart's chambers.
And that brings us to our final ingredient, hypercoagulability. This is a fancy way of saying that the blood itself is just too sticky. It's way too eager to clot. Certain conditions, anything from late-stage pregnancy to severe burns, and even some medications, can actually change your blood chemistry, tipping the scales in favor of forming a clot when you don't need one.
So we have the recipe, now let's see what it actually cooks up because, and this is important, not all clots are created equal. Where a thrombus forms, whether it's in the high-speed arteries or the low and slow veins, totally changes what it's made of and what it does.
And you can really see the difference here. Arterial thrombi, which form in that fast-moving blood, tend to be pale or white because they're mostly made of platelets and fibrin trying to patch up an injury. On the other hand, venous thrombi, forming in that slow-moving blood, are red because they end up trapping a ton of red blood cells. It's all about the speed of the river they're forming in.
Oh, and there's a special subtype we need to mention, the mural thrombus. So instead of blocking a whole vessel, this guy just attaches to the wall of a big open space, like a heart chamber or the aorta. This is often a direct result of those stasis areas we talked about, maybe after a heart attack.
Okay, we've covered the science behind how these things form. Now, let's zoom in on the one you've most likely heard about, because it's one of the most serious and common dangers when we talk about thrombosis.
Yep, deep vein thrombosis, or DVT. This is the textbook example of a venous thrombus, and its biggest danger is that it often forms silently, without any warning, deep inside the muscles of your leg.
So what puts someone at risk for this? If you look at this list, you'll start to see a pattern. A lot of these things, being on bed rest, recovering from major surgery, they all involve stasis or slowed blood flow. This is exactly why you always hear about the risk of clots on long-haul flights or during a long hospital stay. It's all about keeping that blood moving.
Right, it's a hidden threat. But are there clues? Are there any warning signs you can look out for that might suggest a DVT is forming?
And this is the really scary part. A lot of the time, there are no symptoms at all. When there are, you might notice some swelling in the foot or ankle, or maybe a specific kind of pain in the calf. But for many people, the very first sign that anything is wrong is when that clot has already broken free and caused a massive, life-threatening emergency.
So this brings us to the final chapter in the life of a thrombus. Once it's formed, it doesn't just sit there forever. Every single clot is destined for one of 4 possible endings to its story.
Here are the 4 paths it can take. 1, it can keep growing bigger. 2, it can break loose and travel through the bloodstream. 3, the body's own clot-busting systems can completely dissolve it. That's the best-case scenario. Or 4, it can scar over and become part of the vessel wall with new channels sometimes forming to get blood through. The one we really worry about is number 2.
And this right here is the ultimate danger of a DVT, embolization. A piece of that thrombus deep in the leg breaks off, it travels up through the bigger veins, goes right through the heart, and then gets slammed into the arteries of the lungs, blocking blood flow. That is a pulmonary embolism, and it is a true life-or-death medical emergency.
So we end here with this really fundamental paradox. The exact same biological process that stops you from bleeding out from a paper cut can, when it's triggered in the wrong place at the wrong time, become the very thing that causes a fatal blockage. It's a powerful reminder of the incredible, and sometimes incredibly dangerous, balance happening inside our bodies every single second.